from that time, you can see we have some new technologies highly demanded. Okay, so from that time, from year 2001 to year 2002, okay, so one technology was highly demanded. So based on the infrastructure you set, okay, or in all the private domain, okay, so one technology here highly demanded. From that time till the time being, and also in the future, it's called, what's that? Security. Okay, you have a big infrastructure, you have a small infrastructure. Okay, for public domain internet, for private domain, your own enterprise network. Okay, a big one. Okay, like IBM system. Okay, like Bell or Rogers networks. Or you may have a small one you sell for a small company. Okay, they have one head office in downtown and 5 branch offices, okay, in GTA area. This is a small business, okay. Anyway, you have your own infrastructure, you're set, okay. So on top of that, we need to secure our system, okay. We need to secure our system, okay. When your end user visit the system resource, we need to guarantee the data confidentiality. We need to guarantee this communication is not eavesdropped, okay. We need to guarantee the data you received, you send out is original. Okay, you get the message. How do you know this is original? How do you know it's not modified during the transit? Okay, you have the infrastructure, the communication is successful, but how do you know this communication itself is secure? Right. So security, okay, was highly demanded technology from that time. Okay, the reason is we do have the infrastructure set up. Okay, we do have a successful communication. We want to make this communication. We want to make the network resources sharing in a secure fashion. So from that time till the time being, in the near future, we can see security is always highly demanded technology. Okay, so now let's take a look at some other period of time. Let's say from year 2002 to year 2004. So what was highly demanded at that time? Which technology in network field? Wireless. Beautiful. Okay. Wireless, it is not a brand new technology. We know even in the First World War, we used wireless, right? We use wireless, we use satellite, we use different type of RF technology or infrared technology to satisfy the business. Okay. Not only for data communication, for industry control system, But now we want to utilize the wireless as one of the means to carry on the digital data, to carry on the digital message, to carry on the voice, to carry on the video, to carry on audio, all in the same type of new means. Okay, this is a wireless means. Okay, before we can see wireless, it was not ratified. Okay, so all the vendor solutions is all proprietary. That means if you have Nortel system, wireless system, okay, there's no guarantee you can work with the AT&T wireless system. If you have Linksys, there's no guarantee you can talk to Netgear, that type of intercompatibility. There's no guarantee. Okay, but from that time we can see IEEE it ratified the Wi-Fi network technology. Okay, so now we can see we have standardized IEEE AO2.1. We have IEEE AO2.11, we have IEEE AO2.16 for different level of wireless solutions. Okay, so it's ratified. Now we can see, we can guarantee. Okay, the vendor A, now you are ready to talk to vendor B. Okay, so your domain, now you are ready to talk to, there are some other domains, okay, by using the standardized product, okay, wireless based. Okay, so wireless at that time, it became highly demanded. Okay, and from enterprise point of view, we can see wireless, it is extension, okay, to extend your network coverage. Before you have to roll out network connection by using the fiber, by using copper, by using different type of visible medium. But now easily we can reach out end user in a parking lot, okay, in a conference room, okay, in a cafeteria, somewhere, okay, in your campus. So this is very flexible, okay. now it turns out very, very successful. Okay, if you bring your own laptop here, you are ready to go to internet because school here has wireless. It's standardized. You don't have to change your network interface card. You can just keep it. You are ready to go. Right. So this is the wireless technology, highly demanded. Okay. Now, from year 2004 to year 2007, so what was highly demanded from that time? So we see we have network infrastructure, we have all the security solutions applied, okay, we have flexible way to reach out the new users, the new end device, okay, PDA, PAM, okay, wireless laptops, okay. And what was highly demanded from that time, based on all these existing solutions? Yes. Or we see IP telephony. IP telephony. IP telephony is not VoIP, voice over IP. Make sense? Okay, voice over IP, it means we want to packetize your voice, which is the analog signal. We want to packetize it, we want to digitalize it, and then we communicate with all the remote site partners in IP-based platform. This is called VoIP. But IP telephony, it means we use the whole IP component, okay, to reshape all the voice services. Okay, so before we have very legacy, voice solution. Okay, it's PBX based, right? It's PBX based. But now you can see we do have PBX, but that is IP box. Okay, it's called Cisco Call Manager or Cisco Unified Communicator, something like that. So it's a pure IP implementation. Okay, so we get rid of all the analog component. Okay, we combine all the IP-based component to reach out the end user. Okay, we have IP phones, we have handheld devices. Okay, and for all the intermediate level system, we have the IP-based components. Right, so that's called IP telephony. Okay, it has VoIP included, but it's not VoIP. Okay, so get a clear picture in mind. Okay, voice over IP, it doesn't equal to what? IP telephony. Okay, so at that time, we see IP telephony technology was highly demanded. Okay, so that's year 2007. From year 2007, let's see up to year 2009. So what was highly demanded? Now we have network infrastructure. This infrastructure is secured, and we do have the wireless or the flexible way to reach out end users. Now we do have the new services, IP-based voice services. Okay, so based on that, the technology highly demanded is called QoS. That makes sense? Quality of service. Quality of service. So now you have your wired infrastructure, you have your wireless infrastructure, you have digital data, you have voice, you have video, you have audio, all applications running in the same platform. Okay. So as we know, we have limited resources like clean water. Okay, always that's limited natural resource. The same story for your digital world. Okay, you have limited system resources. Okay, always we see the limited system resources, including something that you do really know, CPU cycles. Now you may have a strong CPU, you may have high-profile CPU, but your CPU cycle, it is limited resource. Okay, you cannot spend all your CPU on one type of process. Okay, otherwise your system is down. Okay, or from your end user point of view, your system performance is getting very poor. Okay, so CPU or CPU cycle, this is one of the system resource we need to conserve to make your system performance optimized. Okay, memory. You see, I want to have a 128 gigabyte, or I want to have a certain amount of the memory. Okay, memory here, this is a generic word. It could be a buffer. Okay, interface buffer, interface cache memory. It could be DRAM. It could be some other type of memory. But this is limited. For all the computing machine, this is limited. Right? Now, if you have all those type of applications up and running, how you can